Believe it or not, mobile robotics like NASA's Ingenuity are quietly revolutionizing industries in our daily lives. From sorting packages to exploring space, these robots are becoming more powerful and complex than ever before. With light detectors, sensors, cameras, GPS, and wireless communication devices on board, their capabilities are impressive. But here's the catch. The more features they have, the quicker their batteries drain. The answer lies in smart power management, and that's where a good DC to DC converter comes in. With the right technology, engineers can extend the runtime of these remarkable robots.
Welcome to Tech Chat, sponsored by Mouser Electronics. On Tech Chat, we meet with engineering experts to learn about the latest technical innovations that are shaping and reshaping our world. Today, I'm happy to welcome Joel Zanes, Product Marketing Manager at TDK-Lambda. Welcome to Tech Chat, Joel.
Thank you for having me.
Yeah, we're good to have you here. And what's your topic going to be today?
So today, we're going to talk about how to extend runtimes of your battery-powered mobile equipment. So in the realm of mobile robotics, so we're going to focus on how do we help conserve battery so that you could extend that runtime of your critical equipment.
Well, that sounds like a pretty important topic today, so I'm excited to get started. So let's jump in.
So in terms of mobile robotics, we see a lot of market uptick in the utilization and transition to a lot of this mobile robotic adoption. Most of them are primarily driven by workforce and labor constraints. We're finding expansions of use case and applications, from traditional logistics warehousing robotics. It's now expanding to even medical therapy treatment robotics. We see a lot of expansions towards inspection of utilizing mobile robotics. So those are some of the trends, and these are primarily enabled by the advancement of technology, right? So you're talking about advancements in sensors. You're talking about advancements in 5G networks, fast throughput of data, so data can be analyzed real time and then reacted upon real time, right? Aside from those sensory devices, it just morphs into a lot of these applications enabled by a lot of this newer technology. Now, on the flip side, it also enhances a lot of these worker safety requirements, right? Instead of sending people up scaffoldings, perhaps, now you have mobile robotics, drones, for instance, doing this, inspections in critical areas. Could be underground, could be in high altitude locations. And then, of course, you always have that benefits of when transitioning to automation and robotics, you always have that increase in productivity, the sustainability aspect of it. It just opens up a lot of possibilities.
Yeah, I can see why any one of those would be driving innovation in this field. But with all five of them together, that's why you get those really big growth numbers down there in the lower right corner, isn't it?
Correct. So these are the available online information. You'll see a lot of this online data, but the examples that you see here from a market data is from our friends at Interact Analysis. Significant growth rates for a lot of these mobile applications. So talking about market trends and drivers for this mobile robotics, right? As we demand a lot more of this mobile equipment, the complexity and the functionality actually gets more complicated too, right? If you look at the left side, you'll see a Type A type of AMR, autonomous mobile robot, right? And as you progress, going to Type B, Type C, Type B, now you're kind of adding, for instance, a passive attachment. This happens to be a top conveyor attachment. And then if you go to Type C, this is when you're having more articulated arms, there's more manipulators involved. Based on the ANSI standard, they would classify Type C as something that would have 3 axes or more. So the trends that's been happening, it's also attracting a lot of this standardization, especially when it comes to safety, because a lot of this mobile equipment actually works around not just other robots, but also around other human beings. So one thing that's common from Type A, Type B, Type C is that everything is being powered up by the same battery, right? From the same battery of the base AMR, right? So as you progress from left to right, Type A to Type C, you demand more from the battery just because you're attaching more manipulators. You demand this equipment to actually do more. So yeah, it actually increases the payload to the battery. So let's take, for instance, this particular AMR from, this happens to be from Omron. And these are from published datasheets, by the way. Full transparency, we don't have any relation with Omron. but I just picked this one from what's available online. So based on the datasheet of this product, it says, okay, for this particular LD60 version, this can actually run 13 hours with no payload. And it's based on 80% duty cycle. This happens to be, having a battery that's able to sustain about 1.5 kilowatt hour kind of in a nominal operation. So if you try to do the math, it's probably consuming about 115 watts just based on the math, based on published specification. Now, if you remember from the previous slides, there's actually attachments that are being added to this AMR base, right? Just because we're demanding more from these robots to perform other duties, other tasks. And those are being powered from the same battery of this base AMR. So this base AMR actually provides, several output voltages, 5 volts, 12 volts, 20 to 24, something like that, right? And, the datasheet gives you what's the maximum available current from all of these outputs. So if you try to consider having attachments that, say, may utilize a lot of these voltages, these available rails, and let's say, for instance, it runs, whatever the maximum rated currents are, you're actually drawing more like 373 watts on top of your 115 watts. So in a sense, your 13-hour runtime, assuming you're utilizing all of these DC rails to power up your other attachments, your other sensors, your other articulators, this 13 hours could actually just, run down to about 3 hours, right? So if you're tasking a robot to perform some critical tasks, it's critical that you actually are able to, continuously operate in a given task just to complete the task and then increase your productivity based on whatever the parameters that had been.
Well, that's a pretty shocking revelation there, Joel. I'd never seen those numbers and how significantly it can reduce the runtime just by adding the auxiliary components. For companies that are planning their logistics systems, they're going to need more robots. And so anything you can do to reduce that power is going to help them.
Correct. On this side, we've talked about the reduction in the runtimes, right? The consumption. Now let's talk about, the other complexities involved. Given that these mobile devices actually operate and communicate alongside other robots and other humans, part of the complexity is actually adding more sensory, vision, and navigation type of interfaces or even devices on the actual robot. You'll see on the pictorial here, this is for a particular drone inspection robot, right? As you could see here, it operates from a 44-volt battery. But you see a lot of voltage translations or voltage conversions to actually power up your camera 24 volt, your CPU perhaps, your USB or 3.3 volt networking, right? So there's multiple battery voltage conversions that exist in some of this sophisticated equipment, right? It's not purely run from the same battery, but there's a lot of conversion that's happening from within the equipment. So that kind of adds the complexity. And then if I go to the next slide, we've talked about the sensory navigation. This is another readily published information online. This happens to be another AGV from MIR. You'll see on the gray box there, you see a lot of the components, the sensory navigation and things like that. That's really making this a little bit more sophisticated and complicated just because it has to work in an environment where there's other workforce in there, there's other people in there, there's other equipment that's happening, say, in a manufacturing floor shop, right? So all of these complexities, these cameras, these laser scanners, they're actually powered from the same battery that's present in the AGV. That's not only running the AGV itself to move, but also powering up this other sensory. And then the ones that you see on top, this gold shaded area there, it actually provides additional 48 volt output and 24 volt output. Again, for external attachments, right? It could be another conveyor that you put on top of here, or maybe other articulated arm that could be mounted on the same AGV. So again, as we demand more of these mobile devices to do multiple tasks or extra tasks just to help with the productivity and throughput of any process, then it actually increases some of this complexity, not just from design implementation, but from a battery utilization.
And Joel, are all these voltages and currents that you're trying to put out here from these batteries, because there's so many different levels and they're switching on and off a lot of times, is it even more difficult than it would be for running out of a wall voltage?
Correct. Yeah, because what you will need to incorporate in some of the systems are, to extend your battery run times, really utilize your battery charge or utilize some of these conversion to be more efficient. You don't want any wasted power or wasted energy that's going to come from the battery. You want all of that charge to be utilized, driving what it's needed from all the sensory aspects and all the communications aspects, and really to drive that output, right? You don't want any wasted energy there. And then if we go to the next slide, this is just a typical lithium battery, 48 volts. Again, if you look at the specifications for the battery, they do have some minimum voltage levels that you would want to avoid operating the battery beyond that region or below that region. Some people would call it as, kind of point of no return for batteries. You basically damage the battery, operating it from far down that range, right? So again, what's critical here is, as the battery discharges, you would want to watch where you keep that battery voltage levels, right? You want to extend the life of the battery, not just the charge from itself, utilizing the charge efficiently, but also making sure the battery runs longer in terms of its reliability and things like that. So one thing that you would want to avoid is operating it way below, whatever that cutoff voltage is. So again, if you're trying to convert battery voltages to other DC levels to support your other payloads in your system, you would want that conversion to be as much as efficient as possible, not so much of a strain to the battery. Now, from a TDK-Lambda perspective, we actually offer non-isolated DC-DC converters. We'll talk about it in the next few slides, but these are buck converters, buck-boost converters. These are board-mounted devices that we've seen a lot of good traction for battery-powered applications, especially in the mobile robotics aspect. So it ranges from 100 watts all the way to 750 watts in both a buck step-down converter and a buck-boost converter.
Now, Joel, non-isolated might be an unfamiliar term for some people in our audience. Can you explain what that means?
So non-isolated would mean basically you have a common ground between your input and the output. In the realm of the battery side of things, being powered from a battery, such isolation is not required. So having the non-isolated versions would give you that benefit of higher efficiency. It would give you the benefit of smaller form factors, higher density, right? You're able to remove some of the bulky components like the isolation transformer. You're able to simplify some of the feedback loop, bridging from secondary to primary side. So a lot of bulky components, you're able to eliminate those. And for the same PCB footprint, you're now able to pack more power. You're able to beef up your powertrain. In this slide itself, you'll see small form factors that can actually deliver, up to 750 watts in some cases here. Now, if you look at if we go to the next slide, this gives you some of the high-level operating ranges of our buck and buck-boost converter offering. You'll see here that it's actually have wide input ranges, 9 to 60 volts. So it can cover, multiple input sources, battery sources or battery voltages, for instance, from 12, 24, 36, or even 48, right? And then with its wide output adjustability, most of these have very wide adjustment ranges from 3.3 up to 48. We even offer some non-isolated that has a negative output voltage rails. But as you could see where the voltage ranges are, this actually ties very well to some of the industrial loads that are a component into some of these mobile robotics, right? So it could actually power up your 36-volt motor, 24-volt motor, 48-volt motors in some cases. It could actually power up a lot of your sensors that goes above higher voltages. A typical non-isolated, usually in the realms of telecom and computing space, they're usually targeting a lot of the low voltages, like, maybe 3.3 volts and below. Now, what TDK-Lambda brings to the table is, okay, for the same non-isolated offering, giving you the benefits of high efficiency, high density, we're now able to support higher voltages to actually power up industrial loads. You could see the efficiencies here, up to 98%. And then we offer multiple types of mechanical attachments or mechanical configurations. Again, giving our customers the flexibility to adopt the modules to actually how they would cool their end system. And then it also comes with a bunch of these feature sets, remote on and off, trim, and I'll talk through that in the next slide.
Great. Now, Joel, does the efficiency, I would think it would have a kind of secondary benefits here is that you're not wasting power. That's obvious. But then you're generating less heat, so it's easier to cool. You mentioned higher density, therefore it's lighter for carrying that around. So is that kind of have the benefits of that efficiency really go beyond just the power itself?
Correct. As you mentioned about heat, right? So battery doesn't like heat. Aside from not driving it well below its cutoff voltage, otherwise you damage it. But the heat itself is also something that most electronics hate, right? Otherwise, you're sacrificing or shortening its reliability or its useful life. In terms of product feature sets, the i3A, i6A, the i7 series, and even the ruggedized series of RGs, it actually comes with basic feature sets. You have your typical on-off. If you happen to have the equipment in idle mode, maybe you could turn it off through this on and off enabled pin. That way you could preserve the battery draw, right? The trim pin, that's the one that allows you to adjust the output voltage through resistor programming or voltage programming, from as low as 3.3 all the way to 48 volts. So that kind of addresses the industrial type of loads that I mentioned earlier that these non-isolated modules are able to drive, right? Now, it also comes with optional feature sets. You've got power good, which is really just an indication of, hey, is the output kind of within the set point with the required regulation band, right? In some cases, there's a need to synchronize the switching frequency, helps with some of the EMI filtering, EMI mitigation. Output sequencing, it also has some output sequencing capabilities. So in the event you have certain DC output trails that you want to turn on first before the other ones, then you have that capability and flexibility. The current monitoring feature, that's the one that gives you an analog readback on how much current draw is from the load that's being supported by the DC-DC load. So in some cases, for applications, they really monitor that load draw, load consumption. You could actually eliminate a lot of those sophisticated circuitry and utilize some of these built-in features that say for instance, the i7C or the RGZ provides that could actually sense the load current, right? So again, trying to help customers realize some space savings and at the same time, making it easy for them to deploy these units and eliminate some of those external components that they have to add, right? And of course, we have the current limit adjust. I think I have a slide about this, so I'll talk about that on the next few slides. So now let's talk about these types of converters that I've just shown you, right? So we have a buck or step-down converter. As you can see in the slide, for as long as the input voltage or your battery voltage is higher than your desired set point, then yes, this is the buck step-down converter. It regulates the output. It sets the output on the dot for as long as you have a higher input source, right? And then when you do the boost converter, this is when you're having, when your battery voltage starts to discharge and then you want a higher voltage than what that battery level is now, then you would need the boost converter to actually boost that voltage up and regulate it to the regulated set point, right? And then if you combine these two, then you actually have two converters in one that would be able to step it down and step it up at the same time. So regulate the output regardless of how your input voltage fluctuates, right? So again, it lends itself well for battery-driven type of applications, right? Whether you have a battery that's fully charged and eventually it starts to decay. But even with that decay, if you're using a buck-boost converter, then you're able to maintain that regulation when your battery is at a high voltage level charge or it goes at a lower voltage level when it starts to decay, right? And then lastly, the buck-boost with programmable pass-through. Again, this is another way of enhancing and really driving efficiency for your applications wherein you're really just passing through whatever that battery voltage down to the load. So if your load is not sensitive to any voltage fluctuation, some converters, you could program when it should step down and when it should step up. So that's kind of what that programmable pass-through is. So, you're just basically passing through a battery source voltage all the way to the load within a predetermined kind of voltage guardrails. And then this is a high-level snapshot view. I've talked about the power levels, the input ranges, and then the output adjustment ranges. So you'll see here from our i3A series all the way to the i7C series, we actually cover both step down and then step up, step down in one converter. So these are the buck boost, right? you'll see the power levels. We range from, as low as 75 watts all the way up to 750 watts. So really we are able to drive even high power demanding applications. And if you look at the input ranges, 9 to 53, 18 to 60, those are kind of the sweet spot for a lot of the industrial type of battery voltages that are being utilized to actually drive your load. And if you look at the output voltage ranges that we have here, 3.3 to 24, 3.3 to 40, in some cases we go down to 0.8. These are the ones that would drive a lot of the sensory devices, a lot of the communication devices, all of those telemetry kind of sensors and other components that are being added into a lot of this mobile equipment. And then form factor wise, a lot of these are actually common footprints, industry footprints. It's ranging from a 1/32 brick to a 1/16 brick configuration. So again, familiar industrial form factors that are out there.
And Joel, I would think that it's really important for people that are thinking about buying DC to modules for this kind of application to get really high quality ones, because the electronics that sit on the end of these are really sensitive and really expensive. So if you kind of get cheap with your DC to DC converter, you're putting at risk the electronics that are the more expensive part of it. And it's probably really just not a great use of your money.
That's correct. Especially, we've talked about a lot of these sensory devices, mostly for safety requirements. Because remember, these mobile robotics are actually working alongside other robots and other humans. So yeah, safety is a big factor there. So you need to make sure you're really powering those things up, reliable solutions, reliable voltage conversion solutions. That's definitely the thrust of this product line. So on this next slide, a lot of this mobile equipment, you'll also see some of this robotics that goes into dirty environments, right? Some of them, we have quadrupedals, four-legged robots. Some of them, they actually do cave mapping. Some of them run into rugged terrains. Some of them into wet environment. Power washing drones, for instance, the one that cleans sides of your buildings, your rooftops and everything. So those could be exposed to a lot of these elements. And a lot of them are moving equipment. So we have ruggedized versions that are actually encapsulated solutions in 5-sided metal cases. And these are really geared for conduction cooling. A lot of these equipments are outdoorsy equipment, so no fan cooling, right? So you're relying on natural convection. But in most cases, since a lot of this equipment have a lot of metal in them, you could actually utilize that for cooling, conduction cooling, so heat transfer basically. These products have been qualified to 810G, mil standard 810G for shock and vibe, survived, rigorous amounts of qualification. And aside from being rugged and encapsulated, this actually happens to be even lightweight, right? So, even for payload-sensitive applications, could it be flight applications for drones, or even mobile robotics for ground applications? Because remember, as you add weight, it adds payload to your battery. So having weight-sensitive type of solutions, it lends itself well to a lot of these applications. Now, let's talk about the footprint for this one. I mentioned earlier, these are all industrial type of footprints, right? So if you look at the basic pinouts of the products that I showed earlier, i3A, i6A, 7A, and 7C, right? The basic pinout itself are very common. So in a sense, for a customer who's actually, laying out the board and things like that, based on the commonality itself, TDK-Lambda can actually cover you from 100 watts all the way to 750 watts. So especially when it's kind of early in the development, maybe the power levels and the power budget have not fully settled yet. If you lay out some of these solutions on your board, we could actually cover you with scalable solutions in this case, right? From 100 watts to 750 watts. And then in the same way, maybe this is already deployed. You had some newer technology that maybe pulled back on the battery consumption or power level consumption, then it's easy to scale you down from a bigger brick to a smaller brick. Gives you the benefit of some savings there. Really, it's the engineering investment that you try to save on too, right? Instead of redesigning your PCB to accommodate a new footprint, since a lot of these pinouts are common, and you could actually scale it down on the same PCB footprint, maybe with just minor adjustments in your external components. This is another way of how do we help customers, especially in this space wherein development time, we're always pressed for a shorter development cycle. This is another way of foolproofing your design, allowing you to scale up, scale down on your power requirements.
Yeah, that's interesting. And I would think it would also provide some advantages potentially for their inventory control. They could have a single board that gets used in a couple different applications and they just swap out the power module for it and whatever other components, like you said. So it can help with their logistics and inventory management. And so that, kind of other indirect benefits to companies.
Correct. I think I have that in one of the slides. I'll touch on that a little bit. But yeah, that's primarily all the hidden benefits that are probably not obvious to a lot of our customers because they deal with, okay, part number, volts and amps, but maybe footprint, number of SKUs. Those are the things that, all come into play when you try to look at, from start to end, right? Now, let's talk about the mechanical variations. A lot of these solutions that I've shown you, they're being offered as open frame. Right? So maybe for applications that are chasing the lowest profile, some of these modules go down to, 0.4 of an inch. So maybe the low profile suits that particular need. If there are applications wherein maybe I have some forced cooling in there, airflow, I have some height benefit, then we actually offer some heatsink versions to really capitalize on the cooling itself. And then for applications wherein, hey, I don't have any fans, it could be in a sealed box application, then yeah, we have a base plate solution for that, wherein you could actually conduct the heat or transfer the heat from our base plate to, whatever the metal frame is of the chassis. And then again, for applications where there might be high shock and exposure, then we have ruggedized versions that could also cater to that are fully encapsulated with qualified to high shock and vibe, right? Now, the good thing about some of these conduction cooling and these ruggedized solutions is that, for as long as you could cool the base plate well below the maximum that we specify, you're almost guaranteed to actually draw and utilize the full rated power. So that's kind of the benefit of some of this. The customer will only have to watch for, hey, one case temperature instead of, hey, multiple components in a board, right? We'll just give you, okay, for this particular solution, just measure this case temperature. For as long as you maintain the temperature well below the maximum, then you're good. You're not sacrificing the reliability. You're not shortening the life of the module. It's an easy check, right? In some customers, we actually provide them thermocoupled solutions or samples, right? Just to allow them to really measure the temperature in the actual use case. It's always different when you're characterizing a module on the bench versus in the actual use case. So we provide customers with thermocoupled solutions, really allow them to vet and measure the product on an actual use case deployment. Now, there are also applications in, hey, I want everything to be controlled. I'd like to adjust my voltage through digital means, right? We actually have some application notes. You could actually inject an external voltage to the trim pin. You could communicate that through I2C via an external DAC. So we have application notes that support that capability. So again, how do we help customers simplify their implementation, right? Rather than having, a huge chunk of external components, external hookups to drive and adjust the voltage. Here you have a few parts that you could actually, servo your output voltage up and down through I2C. Now, we have solutions that actually have adjustable overcurrent limit protection. So with the help of one external resistor, you could actually program the overcurrent limit of the module. So for instance, if you're talking about a 750 watt converter, and maybe the customer's load is, only 350 watts or 400 watts. With the help of the overcurrent limit protection, you could actually adjust that current limit much closer to your 400 watt level, such that whenever there's some excessive load behavior, then the module can actually protect the load or protect the module itself from excessive overload. So again, another way of implementing some of this capability through one resistor that has the feature built in already in the module. So it eliminates the need for our customers to actually add additional components, like another layer of protection outside of the module itself. So here, with just one resistor, then the customer can actually fine-tune that into whatever the protection levels they need it to be, how close it needs to be to the load.
And I would think that you talk about this protection because it's protecting the electronics, but indirectly, going back to the worker safety and everything, it's protecting them because the system is getting more information that something is not going right, whether it's on a sensor or on a drive, it's moving a motor, anything like that. And so that really becomes important for helping to ensure overall system safety.
Correct. Instead of damaging high sensitive equipment, sensors and things like that, fine-tuning that to the right level, then you're protecting not just the module, but the sensors itself from, going into any overload condition. If we go to the next slide, this is really the value that these products bring to the table, right? So you have wide input range. We've talked about that previously. It operates seamlessly from various, battery voltages in this case for mobile robotics, right? Caters to 12 volts, 24, 36, 48. So one part number, right? You could cover multiple input ranges, multiple battery voltages. It has a flexible output adjustment. We've shown that earlier. In some cases, 3.3 to 40 volts output or 48 volts output. If you're using multiple DC voltages, converting it from your battery input to drive a gamut of sensors, lidars, cameras, and things like that, then with the help of these wide range capabilities of the adjustment range, wide range of the input range, then that supports the other thing you mentioned earlier. From an inventory standpoint, you just worry about one part number that could actually cover multiple DC rails, right? So from an inventory standpoint, from a BOM management standpoint, then we're keeping it to few number of SKUs. And then we've talked about higher output voltage. It's really driving those industrial loads, motors, your actuators and things like that. So it goes higher voltage, 48 volts for instance, right? And then we've talked about the footprint commonality. So you were able to scale your power requirements. So we provide scalable solutions from 100 watts all the way to 750 watts. And then we did talk about lightweight solutions, ideal for payload sensitive applications, things that gets exposed to high shock and vibe, right? And then being lighter weight, then it helps with the overall payload for, a lot of these robotics. Weight translates to some burden on your battery, right? You're having to drive the wheels and the motors a little bit harder just because of the added weight. And then, of course, the adaptable cooling. So depending on what the use case is, then we've got the customer covered. You've got forced air, then we've got solutions for that. You mount it in a sealed box environment, no airflow, then we've got the base plate for that, or the ruggedized version for high shock and vibe. So really the goal here is allow the customer to really focus on the core side of their development, right? We give you the tools and the flexibility with all of these solutions for power, give you that extensive range of solutions. Whatever the use case may be, then at least, you have a standard off-the-shelf part that can actually support your needs.
So Joel, for the designers out there that have seen all this and are really interested in getting started with these TDK-Lambda converters, what should they do? Where should they go?
For these product lines, we actually provide a lot of these tools on our website. We provide the full specifications, the data sheet, that outlines how do you utilize, how do you use the feature sets. The safety files are actually posted on our website. So for customers who would need to go to a safety agency, then all the safety files are actually there. But what's important here is really the eval kits that we provide. So these are readily available from mainstream distributors. Mouser in particular carries a lot of these eval kits that we have. So this is a good start for customers to actually play around with the unit without having to lay out a board or jerry-rig something on a PCB, right? So all they need to do is really hook this up from an input source, maybe connect it to a load that they want to power up and see how it fares in the application. One of the things that TDK-Lambda is good at is really supporting tools, right? Especially for eval kits, for board-mounted products. We don't want customers to be spending efforts on making the decisions on the front end, right? So we give that tool on the front end so the customer is able to make that decision and determination if that solution is actually optimal for what they're trying to power up. On our website, we actually offer the 3D files as well. And we're actually partnered with a few of these EDA tool providers, SnapMagic, Samaxis, and UltraLibrarian. These are the guys who provide the PCB layout, the schematic symbols, and even the 3D drawings, right? So again, the idea here is we offer these tools, we offer all of this so you could actually port it into your CAD software, make the design easier, so that if you determine based on the eval kit analysis that it's supporting what you're driving in the system or as a load, then all of these tools would help accelerate that design process. And then these are all the tools that were derived from actual TDK-Lambda materials, TDK-Lambda CAD materials that are syndicated through these three EDA tool providers. And then from a tools and resource standpoint, you can always start with our website, us.lambda.tdk.com. We have a technical support hotline. You could contact them through email or through phone number. We have 2 FAEs, have their emails there. So if anybody wants to reach out, talk about power, what's the optimal solutions that TDK-Lambda have, then these are all right at your fingertips. And then on our website, we provide a lot of these brochures and catalogs for various types of product lines. And then what's key here is our Power Guy educational videos. These are all talking about industry challenges or customer challenges, all about power. We talk about why do we thermocouple a power supply? I mean, why is EMI so important? How do you mitigate EMI? So we have a lot of those educational videos, plus a lot of the technical blogs that were actually written by engineers for our engineering-based customers.
Well, Joel, that was really educational. I know I learned a lot, and I think our audience will too. So thanks for taking your time today to visit with us.
Thank you for having me. For the engineering community out there, if you come up with any power needs related to this topic, a lot of the DC-DC solutions, battery voltage conversions, feel free to contact us, visit our website. There's a bunch of good information there. And then for your sampling requirements, we carry a lot of our samples for the products that we spoke here through Mouser. So feel free.
And as we end today's tech chat, we do want to thank our friends at Mouser Electronics. If you're looking to purchase any of these great TDK-Lambda products, please head over to Mouser.com to help them continue to support educational presentations like this one. And join us again next time on Tech Chat, where we chat with experts like Joel Zanes from industry-leading innovators like TDK-Lambda who are changing our world every day.